Okay, welcome to Chapter H, DHCP. Um, in this chapter, we're going to be covering how you can turn your router and or switch into a DHCP server. Basically, for those of you that may not know what DHCP does, that it is the program or the protocol that actually issues your PC the IP address. This is typically done with the server, such as Microsoft server or Linux server, but you can do it with your router and switch as well. So we'll go into that here. Okay, so in Chapter 8, we will cover the DHCP for IPv4 and the DHCP for IPv6. We'll explain how DHCP operates, how to configure your router and your router client. And then on the DHCP6, they have two different types. They have a stateless and they also have a stateful. These are both pretty easy to program. On here, it's only showing you how to do it on a router, but it's pretty similar on a switch. And when you work on the labs, you will see that. Okay, DHCP version 4. Okay, so like I mentioned before, what DHCP does, it assigns an IP address to your device, whether it be your home computer, tablet, your notebook, telephone, whatever you want on there, and it can be configured to do this service. And like I mentioned earlier, typically you would have that through your hardware server, but if you don't have a server, or I'm sorry, like software server, then you can do it. And you can also create what are called leases on your IP addresses. So if a machine does not use the IP address, it will be returned back to the pool, and then it will be generated for another machine to use. Like it says here, it says the client's going to ask for an address, and then your router or your DHCP server or switch will return an IP address to it. Up to this point, you've been manually putting in the IP addresses on the clients, but with this particular chapter, the router and switch will be the ones that will be issuing the IP addresses out. The way it pretty much works is your client is going to request an address. If the device is capable of it, it will return with an address. Then your client says, I will accept the address, and then you get an acknowledgement. These are basically called handshakes. And then to renew, all it does is, I need another address. Can I renew it? It shoots it over, and then it will kick back again. You can also do it at the DOS prompt by using ipconfig/release, and that releases the lease, and ipconfig/renew, that will renew your IP address from your server or router. Okay, this is just the messaging format. You don't have to really need too much in here. It's just that this is your client and this is how many bytes it uses. This is your IP address, your server address, gateway. This is basically everything you transmit and receive from when you do get your IP address from the DHCP server. Here, this is another example of the discovery in the message. It doesn't have an IP address, so it goes to the client. Then the client comes to the server, and then here's the way it looks. The IP address, it actually begins with the MAC address first, goes over, and then it uses a UDP protocol, because remember, UDP is the one that is where it actually stores and forwards, so it's a more guaranteed protocol when it comes to getting information back on that one. Then after it gets the information, then it looks at the source, and then it's going to give it, okay, I have this available in the pool, so it's going to go back and give the PC back that IP address. When you're doing a basic DHCPv4 on a server, you would actually log in through the console port into the server, and then you would actually be setting up the pools. What the pools are is the range of numbers that you will be actually like assigning to the pool. Over here, you would type in IP DHCP excluded addresses. So these will be the ones you won't be using. Excluded, this one you won't be using. And then the ones you will be using will be from 192.168.10.0, and then the subnet mask, the default, and then of course the DHCP server. These are used because it can be used as the address of the server or the default gateway or whatever you need it to use. So that's why you need to exclude the addresses you don't want to use first, then use them down here. Just like all the other commands within the router or switch, you will use the show command. Here you could use the show running config with the pipe and select a DHCP. You can check to see how it's binded together, and you can also check the actual stats of the information. Like I mentioned before, on the PC at the command prompt, you can type in ipconfig/all, and this will tell you every detail about your NIC card on your device, including IPv6, DHCPs, and anything of that nature. The labs that we'll be doing will be kind of like a relay thing where it will be issuing out to certain devices. You will be getting IP addresses out, and then the devices will be getting them from the pool that you have assigned to the router that you have. Problems can occur if you overlap IP addresses or if you don't exclude an IP address that is currently being used by the device that is either the gateway or the one issuing the IP addresses. Here, all you would do is you would type in, let's back up for a second. The IP helper address enables the router to forward a DHCP the broadcast to the DHCP server, so connect to the relay. So this pretty much is like a forwarding agent to help forward the addresses through this interface on here. And if you notice, it will show you the helper address and push it through. Configuring it on the router, you would type in the interface you need, gigabit, or you could FE for fast Ethernet. And then you type an IP address, a DHCP, because they will pull it from the pool, and then no shutdown. This is just like you normally program, except for you don't put the IP address in the subnet mask. You just put DHCP, and that will pull it from whatever pool you have programmed as on the server. On a wireless router, you can do the same thing. You can come in and do an automatic DHCP, which the majority of them are already set that way. You can also go in and you can create static IP addresses. On your wireless devices, though, I'd be very careful with setting it up because you don't want to have any conflict with your provider or service provider that you have. So I would pretty much leave it on automatic on that. Troubleshooting, you want to resolve address conflicts. Like I said, make sure you put what you want excluded and excluding first and do it. You want to verify connections. Remember, I always say, look at the lights, look at the lights, look at the lights. If you do not have lights, that means you do not have connectivity or you have not programmed one side or the other. Test the address, always ping it, and also do a tracer-T or trace route to make sure that it is going all the way through. Verify the ports on your switch. Like I said before, these are watch your lights, watch your lights, watch your lights, and also to make sure that whenever you are doing subnets and VLANs, that all the devices on the subnet or the VLAN are on that subnet and VLAN. It is very crucial. If you have a device that is not on either one of those two, it will not work regardless of how you have it programmed. So that's just something to be very careful of. Verifying when you want to verify the DHCP version 4, it's basically show running config or show run with a pipe symbol, and then you select the interface you want to look at, and it will show you the address it got and also its helper to help forward it through. And then when you want to debug it, you can create access lists, which we just covered last chapter, and then you can go through and then you can actually run a debug command on here to do it. Remember, anytime you want to stop a command or you want to reset a command, always put no in front of the command. So in this case, to begin the debugging, it would be debug IP DHCP server events. Then if you wanted to stop this, it would be no debug IP DHC server events. So just remember, anytime you put a command in, whether it be programming or the debug, always put no in front in the majority of the cases to reverse the command or stop or change the command. Okay, finally we have 8.2 DHCP version 6. This is kind of the same thing, except for it uses what is called stateless address auto configuration, which is kind of how you would pronounce like DHCP on IPv4, but now they call it Slack. You can see the requests and the requirements for it, and just like before, IPv6 also does what are called the handshakes, where it asks, verifies, and then here's another one. It asks, it needs one, and then it will check across. And then, of course, IPv6 too, a lot of times use what are called flags. Flags be either ones or zeros, or remember, ones and zeros also represent yes and no on that. Then IPv6, you would do IPv6 ND other config flags. This is how you would modify the messaging between the two. IPv6 on an actual DHCP server probably won't see it too much, but as we get more within IPv6 within the United States, you will see more of it coming around. There is a lab that you will be working on that. You will be programming this. Kind of the same lines of IPv4, except for you're going to be using the IPv6 hexadecimal addressing, or the 128-bit address on there. And here's just other ways that you saw from earlier on the handshakes, as for unicast. Then here, of course, IPv6 unicast routing, and then here's where you create your table. This is your DNS address, the name of your actual network or domain, and here are the addresses that you have for it. So it's a little different. We will be covering more of IPv6 actually later on, so all these numbers here will make more sense as we cover it more. Just all you're going to be doing on this lab is just typing in whatever is listed on the sheet, but a little later on you will be understanding what all this means with the : and the /64 and the 2001 or the FE80 at the beginning of the IPv6 address. And here, it's kind of like what you did with IPv4. You do the interface gigabit 01 or whatever port, IPv6 enabled. In this case, you're going to do auto config and not the DHCP like you did with the v4 edition of this. And then, just like any other command you do the show IPv6 interface, and you can also do the debug like you did with the v4 IPv6 DHCP details. And remember to shut down the debug command, just put no in front of it. IPv6 configure, what you do is you're going to say IPv6 unicast routing, IPv6 a DHCP pool, or whatever name you want to give it, the address, the lifetime, where the server is, what you want to call it. It can be school.com, whatever you have as your domain name within your organization. Interface number, IPv6 and the name of the pool, and then IPv6 ND management config flag. Continuing on, you would just come in and tell it IPv6 unicast routing again, IPv6 pool, and it's going to either be stateful or stateless depending on which one you're doing. The addressing, of course, the name, the .com, the interface, stateful, and the flag again. So this is just programming. I don't expect you to actually memorize this. Like I said, you will do this in the lab, but it's not crucial that you know exactly the commands that you see here. And then, like before, you would come in and type in interface gigabit 01 IPv6 enabled and IPv6 address DHCP, just like the IPv4, except for now you put in IPv6 instead of just IP address DHCP enabled. Here again, verifying it, just show IPv6 DHCP pool, and it will tell you what's happening, any conflicts in use, active clients that are connected to it, who's binded to what. You can even check the individual address and check to make sure that it is working correctly. And then this would be the lab that you would be programming. Just like before, you would have the program the interface, check the destination, and show the route. And so just like we had with the IPv4 lab, except for you're replacing everything with IPv6. Like IPv4, same as before, resolve the address conflicts, make sure you're not reserving or using wrong addresses, verify allocation methods, test, make sure, remember this is ping, tracer T, tracer R commands, verify port configuration, lights, test the same subnet, like I said, mentioned on the other one, make sure everybody's in the same subnet or VLAN as well. When you verify, you can come in and type in these commands to verify either stateful or stateless commands. These will be covered more as we go on. Just like IPv4, you have stateful and you have stateless. It depends on what you need to use it for, how long you need to use it, and what type of address it is. And then, of course, if you want to debug it, like IPv4, you're going to do debug, IPv6, DHCP details, turn this off, go no debug, IPv6, DHCP detail. Okay, so summary, DHCP, like I mentioned before, typically would come off of a Microsoft server and or Linux server, but you can program your router, switch, and even your home router that you get for your internet at home. You can do it there as well. You can program how 6 and 4, the client and the server, also IPv6 for v6 as well, or IPv6 troubleshooting, IPv4 troubleshooting. Trying to remember, you would probably use a server or router to do to actually distribute DHCP if you are having difficulties with your actual software server being hacked a lot. You can have this as a backup system, I guess, if you want to. Or if you just have a router switch only and you want DHCP, then you could just use this and not have to. You wouldn't have the expense of actually having to buy Microsoft server or Linux server. Okay, that concludes Chapter 8. Like I said, you will be working on labs where you will be programming these two features. And as I mentioned before, we will be covering IPv6 at a later time in more detail. Thank you.